In this video, we're going to look at histograms with unequal class intervals. We use histograms for continuous grouped data. We've got a picture of a histogram here. This one has equal class intervals. So we can see that each of these intervals is 5 kilograms. When that's the case, we'll have frequency along the vertical axis or the y-axis. If we don't have equal class intervals, we need to use something called frequency density. This gives us now a proportional diagram. So each of the blocks or bars is proportional to the frequency. That keeps our histogram fair. What we're going to do in the video is look at constructing a histogram from a table, and then we're going to look at interpreting a histogram once we have one drawn. So let's start off. It says here the table below shows the length in millimetres of some worms found in Steve's garden. We're asked to draw a histogram to represent the information. So what we have here is the length and the frequency. This is continuous grouped data. So continuous by the fact that it will take any value between 0 and 5, 0 not included, 5 included, and it's grouped because I've taken 0 to 5, 5 to 15, 15 to 25, and so on and so forth. We can see that these classes are unequal. So 5, 10, 10, 20 and 25. We've got the frequency here, and to construct a histogram we need a new column. Instead of just having frequency, we will have frequency density. Let's just introduce frequency density. Frequency density, FD, is equal to the frequency divided by the class width. This gives us the height of the bar that we need to make the area give us now the frequency. I'll explain that as we go. It's fairly straightforward once we've done a few of these. So we've got frequency density is equal to frequency divided by class width. I think it's important to say now that we can rearrange this equation, multiplying both sides by class width, to write that the frequency is going to be equal to the frequency density multiplied by the class width. This is going to help us later on when we need to find how many observations we have in each of our intervals. So what I'm going to do is introduce a new column, and this is frequency density. This tells me how high my bar needs to be. So this is going to be 13, that's the frequency, divided by the class width. The class width is going to be 5. 13 divided by 5 is going to give me 2.6. Don't be alarmed that these are small numbers. I'm going to adjust my scale accordingly. So I'm going to put it on this particular set of axes and then draw a frequency density scale. On the next one, we've got 21, and we divide 21 by the class width. The class width quite clearly here is 10. A common error is students saying 21 over 15. We're looking at now the class width, that's going to be 10, and that gives me a frequency density of 2.1. The next one here, we got 38, and we've got again a class interval of 10. So 38 divided by 10 gives me 3.8. So our frequency density is 3.8. This one right here, we've got 10, so 10 divided by the class width. The class width is going to be 20. That's going to give me 0.5. The next one, we got 25, and we've got 15. So 15 divided by 25, which is going to give us 0.6. If you're unsure, just check on a calculator. 15 divided by 25 will give us 3/5 or 0.6. We can just plug that in. So I've now got my frequency densities. Looking at this, I can now find an adequate scale to draw along the y-axis or the vertical axis. I'm going to say that this is the frequency density. I'm going to say that this now is the length in millimetres. So we have now our classes along the bottom to construct, and I'm titling my histogram. So what do we need to go up to? I'm going to go up to 4. So let's take now this to be 1. So we'll put this on and we'll just change that colour. That's going to be 1. This is going to be 2. This is going to be 3. and this is going to be 4. I can see that each of these blocks now will be 0.1. So on the first one, I need a frequency density of 2.6, and my class width is from 0 to 5. All I'm going to do is get a box, and we're going to draw this on. So 0 to 5 is going to give me 2.6. So let's locate 2.6. 2.6 looks to be about there, and just going across. So 2.6, and then now I've got my 5. And at the bottom, I might want to put on here 5. If we look at the next one, 2.1, and I need to go from 5 to 15. So 2.1 looks to be just there. Let's just do that. And that's 5 to 15, which looks like so. So that gives me a rough idea. So let's just make sure that's right on the line. And that looks about as good as I'm going to get it. So next one, we want the next one, and the next one is going to be in the column from 15 to 25, and that needs to be 3.8. So 3.8, and that's going to be now 10 in width. So I'm going from 15 to 25 and 3.8. So if we do that, that looks to be 3.8, and then we can go across, and this now was 15 to 25, which will look something like that. Now the next one is going to be 20 wide, so we need to go from 25 to 45, and that's going to be 0.5. So 0.5 will be down here, and then we will go from 25 to 45. 45 looks to be just there, and 0.5. Okay, there we go. That's about as good as it's going to get. And then finally 0.6, and that's going to be from 45 to 70. So 0.6, which looks to be just there, and we'll place it on, and then that'll take me like so. So what we now have is a histogram, and we can see that the size of these bars now is proportional to the frequency. A nice little technique that you could use if you're struggling with these often is to count the blocks. Some questions might require us to count the blocks. For this one, it should be fairly straightforward. So this is our histogram, and each of these is proportional now to the frequency of the category. So for example, if I look at this one, this is quite clearly now the largest one, because I can see that the area trapped inside this rectangle is greater than all the others. And we can see that from this particular interval here. It's harder to see some of the smaller ones, but we could just go ahead and count the squares. So frequency density is the frequency divided by the class width, and that now keeps our histogram proportional. Okay, so let's go ahead and do something slightly different with this. Let's now work out the frequency. So what we have then is the following. We have now 5 is just here, we've got 15 just here, we've got 25 just here, we've got our 45, and then our 70. If we go back to our formula, we can see that the frequency density multiplied now by the class width is going to give us back the frequency. So what I'm going to do is hide now the numbers that we've got up here and work out how many were in each of these particular classes. So from 0 to 5, I've got a frequency density of 2.6. So to work out now the number, all I would do is 2.6, and I'd multiply it by the class width. The class width is 5. 2.6 times by 5 is going to give me 13. That gives me back the frequency. I appreciate that's not massively easy to see. Let's see if we can make that slightly easier with the black. There we go, that's slightly better. So all I've done, and I'll just rub that out, to work out now the frequency of this, we've just multiplied the frequency density by the class width, which kind of makes sense as it's the reverse or the inverse or the opposite of what we did before. So this one is going to be, now frequency density is 2.6. We're going to multiply that by the class width of 5, and that will give us back the frequency. So if we were asked now to work out how many people in total there were in this particular survey, or how many worms, or how many whatever it was we were told, we could work it out this way. So if we look at this one, we're going to have now a frequency density of 2.1. So 2.1 is the frequency density. I multiply that by the class width. The class width is 10, and that will give me back now the frequency, which will be 21. If we now look at the next one, we've got a frequency density of 3.8. So 3.8 multiplied now by the class width is 10. That is going to give me 38 observations. That might be people, it might be trees, it might be worms, it might be cars, it might be anything. If we look at the next one, we've got now a frequency density of 0.5. We have a class width now of 20. That is going to give me back 10. So we can say that there are 10 people in here. This one right here, we've got a frequency density of 0.6. So 0.6, and we're going to multiply this by the class width, which is going to give me now 25, and that will give us now 15. So if we were asked to state how many people there were in this particular survey, assuming we didn't have a title, I know it's worms, but it could be anything, we would simply add these up. If we were asked now to find out how many people, or worms in this case, were 25 millimeters or less, then we would simply add these ones up. So that's drawing a histogram from group frequency data or continuous group frequency data chart, and then we've put those on. You must learn this, and hopefully you'll be able to see that if frequency over class width is frequency density, then multiplying these two will give you the frequency back. So let's go ahead now, that's drawing one, and we'd label this up. We'd say that the length of the worms in Steve's garden, etc., and this is now done. That's drawing. Let's now look at interpreting a histogram. So in this one it says, the histogram shows the range of ages of members of a sports centre. So we've got now from here 0 to, we don't have anything in 0 to 15, we start at 15, 15 to 25, 25 to 30, 30 to 35, and so on and so forth. So we can see that these are unequal class intervals. We've got the frequency density up here, and we can go ahead and work out now the frequency from here. So it says complete this frequency table. So all I'd write to myself now is that the frequency is equal to the frequency density times by the class width. If you want a more simplistic way of doing this, the area of these bars will be proportional to the frequency. So if we can work out the area of this bar, that will give us the number. The area of a bar is the length times by the width. So the length is your frequency density, the width is the class width. So if we look at this, now we've got 2, 4 and 6. So we're just here. Now just counting up 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8. It's not massively clear. I'll assume 2 is on this one. So we have now 1.8, and we're going to multiply that by the class width. The class width isn't 25, it's 10, and that's going to give me now 18. So people now 15 to 25, we're going to have 18 people. If we look at the next one, that looks to be 4.2. So 4.2, and we're going to multiply that by the class width. The class width is 5, and that's going to give me 21. Again, if you need to use a calculator, feel free. This one looks to be now 5.6. So 5.6 multiplied now by the 5. So that is going to give me now 28. So let's put 28 in there. This one, we've got now a frequency density. Again, it's quite hard to read. Let's just go up from 2. 2 is going to be just there. So 2.2, 2.4. We've got now 2.6, 2.8, 3 and 3.2. Let's just check that works there. That looks about right. So this is going to be 3.2. In the exam, it will be a lot easier for you to see. So 3.2. This time we've got a class width of 10, that's going to give me 32. This one has got a frequency density of 0.8, each of these blocks is 0.2, so 0.8, and this is going to be multiplying now by 15. So class width is going to be 15 on there, and that's going to give us a total of 12. So 0.8 times by 15 is 12. 0.6 is a frequency density multiplied by 10. That's going to give us 6. So that's our frequency table completed. Again, if we were asked to state the number of people that were 45 or more, we would add these two. If we were asked for an estimate, and this is where it gets quite interesting, if we were asked for an estimate for those, and let's say we went now, we'll pick a number. Let's say we were asked for an estimate between of those between 15 and 20, we could simply split this up. So what we'd do is run now 15 to 20, if we were asked for an estimate for this. We would find now the middle of this, which looks to be just there, and we would see that this would be 5 by 1.8, so it would be 9, and that is an estimate. Remember, this is group frequency data, so we've got continuous, or in many cases continuous. With this is going to be what we're going to have on here. We're going to have discrete, but they could be anywhere in this. So what we've got then is the following. We've got these people. They might all be 16, they might all be 24, so an estimate for those under the age of 20, we would just use the rectangle and find the area. Okay, so that's now interpreting one. Let's look at another question, and let's go ahead and try a different one. Okay, it says here, the histogram gives information about the heights of 540 Christmas trees. Okay, so this is what we've got. We're asked to work out an estimate for the number of Christmas trees with a height of greater than 3 meters. Okay, this time we don't have a frequency density. What we do have is a frequency. So our frequency is 540. There are a few different ways that you could approach this question. What I'm going to do is look at counting blocks. If we look at this seems, and I'll just put on here, this seems to be 10. This isn't very well produced. So often, when you have this in the exam, it'll be a lot easier. So with this one, we could go ahead and count blocks. So that's going to be 40. So if we look here, we've got now a class width here of 10 blocks. This is 10 blocks between the two. So if we just count them up, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I'm going to have here is the following. I'm going to have 10 and then times by 20, which is going to give me 200 blocks. So that's 200 blocks. This one right here, I've got 5 by 35. So let's write 5 times by 35, which is going to give me, what's that going to be? 175. So I've got 175 blocks here. Here I've got now along the bottom 15 blocks. So 15 blocks. And then how many have I got up here? That looks to be 15 as well. So 15 times by 15 is 225. So 225. This one here, it looks like I've got 20 blocks, and that seems that I've got 7.5. So 20 times by 7.5, that's going to give me 150 blocks. So that's what I've got. I've got 200 blocks, I've got 175 blocks, I've got now 225 and 150. So if I add all of those up now, let's just go ahead and do that. Let's just put them here. We're going to have, what's that going to be in total? Let's just put that on. That looks to be, so if we add those two, that's 400. Then we've got on there now 600. So what we're going to have, we're going to have 750. So I've got 750 blocks in total. And I'm just going to write it here. So 750 blocks. We know that 750 blocks represents now 540. So a couple of different approaches. What I'm going to do is 540. So 500, and let's just scribble this in, 540. So 540 divided by 750. This is going to tell me how many trees per block. So this will be trees per block. So just jot that in, trees per block. So in the calculator, let's do 540 over 750, which is the same as 54 divided by 75. That's going to give me now 0.72. So let's have a look at this. This is 0.72. So each block gives us 0.72 trees. What we're looking for is an estimate for those now Christmas trees with a height greater than 3 metres. So if I look at this here, let's just go ahead and split this up. 3 metres is going to be now just this point right here. So what I need is the area of this block, and then I'm going to add to it the block next to it. So these are going to be now the ones that are going to be more than 3 metres. And remember, it's an estimate as it's grouped data. So what we've got then is we've got 150 blocks here because we've got now this base, and let's just put this on. So this is going to be 10, and we'll have now 10 times by 15. So I'm going to have 150 blocks here because I've split this up. We did have 15 times 15. I've only got 10 of them. And then this one, we've got another 150. So I've got 300 in total, so 300 blocks. And all we're going to do is take 300 blocks and multiply it by that number. So times this by 300, and that will give us now an estimate. So 216. So that would be my answer. So we just do 300, let's write it just here. So 300 times by the 0.72, and that gives us 216 as an estimate. That's one way of doing it. So counting blocks and splitting it that way. There are other alternatives. I chose that method as we didn't have a frequency density here. I just picked the blocks and then worked out areas relative to the size of what each of these blocks were against the population. So there we go. That's now a brief introduction to reading and also interpreting and drawing histograms for unequal class intervals.